Today's episode has an awful lot happening on the International Space Station, from a spacewalk to an art piece to not one but two CubeSats being yoked into orbit.
Plus, a NASA astronaut is prepping to return to Earth, and the Gaia mission tells us just how big some white dwarfs are. And finally, Eric has a macro lens to review.
All of this and more is coming at you right here on the Daily Space.
I am your host, Dr. Pamela Gay.
And I'm your host, Eric Mattis.
And we're here to put science in your brain. Last week, we addressed some concerns about just how and when one of the International Space Station astronauts would return to Earth from the ISS. Under normal circumstances, a return trip on Soyuz wouldn't even be something to talk about. But with the war in Ukraine and Russia's ongoing sanctions against opposing countries, we had to rely on NASA's reassurance that everything would be fine and that there are backup plans in place. With all of that in mind, on March 24th, NASA announced the planned coverage for the return of Soyuz MS-19, where American astronaut Mark Vande will be returning with two Russian astronauts, Pyotr Dobrov and Anton Shkarplerov. Dobrov and Vande will be returning after 355 continuous days in space, which set a new record for American astronauts by 15 days. The first event will be the morning of March 29th, when the current ISS commander, Anton Shkarplerov, will transfer command of the ISS to NASA astronaut Thomas Mershburn in a symbolic change of command ceremony at 13:45 UTC. Just under 9 hours later, at 0230 UTC on the 30th, there will be three events: hatch closure at 1200 UTC, undocking at 0321 UTC, and the deorbit burn, followed by the landing at 0728 UTC in Kazakhstan.
We mentioned last week that there was an EVA coming up. It took place this week. There were some minor equipment problems, but the EVA was completed fully and safely. The purpose of this EVA was to add hoses to the module which circulates coolant around the station's radiators. It started at 12:32 UTC on the 24th and lasted 6 hours 54 minutes, exactly the same time as the previous EVA, which was purely a coincidence. From the beginning, the German astronaut Matthias Maurer had problems with his spacesuit. Right after departing the airlock, there was a problem with the cable for one of the glove's heaters, so he was forced to go without heaters in the glove for the duration of the spacewalk. Then, one of the cameras on his helmet came loose and had to be secured with wire ties by the other astronaut, Rajachari. The helmet cam is a critical piece of equipment as it allows ground control to see what the astronauts are seeing to help with any problems. With those issues resolved, the astronauts went on to complete their primary task, installing the hoses from the radiator beam valve module to a radiator. The astronauts worked different tasks at the same time, with Maurer first running some Ethernet cables to a platform on the outside of the station, before helping Chari with the radiator. The platform will be used to host commercial payloads for European customers. The astronauts wrapped up the spacewalk by installing a new HD camera on the outside of the station. After finishing tasks, the two astronauts re-entered the airlock and repressurized it. Maurer was first out of his spacesuit because he noted that almost 50% of his faceplate was covered in water. A leak like this has happened before during a spacewalk in 2013. In response to that, NASA added a helmet absorbency pad to absorb future leaks. Unsurprisingly, the hap on Maurer's helmet was damp. But both spacewalkers were okay overall, and the EVA was considered a success. This past week, the American Astronomical Society's annual Goddard Space Symposium was held. Typically, it has had many different panels, and this year was no different. During one of the panels on the second day, Jared Riekwald, Senior Director of Space Logistics, a subsidiary of Northrop Grumman, mentioned that they are working on an unsolicited proposal to service the Chandra X-ray Observatory. This space telescope is one of only a handful of operational X-ray space telescopes, and it will mark 23 years in space this July. The current servicing spacecraft that Northrop Grumman operates is called the Mission Extension Vehicle. Essentially, it is a standard satellite bus with extra fuel and a grabber on the front end to take hold of a customer satellite and move it into a different orbit or maintain its current orbit. The satellites that the MEV has worked with to date have been in geostationary orbit 35,789 kilometers above the Earth. Chandra, however, is in an orbit a third of the way to the Moon, or almost 4 times farther away than geostationary satellites. It will need a much larger rocket, such as SpaceX's Falcon Heavy, if not something more powerful, to reach Chandra. It is not clear that Chandra even needs a servicing mission at this point. And there's the risk of propellant residue from the MEV inadvertently damaging the sensitive optics of the telescope. So the question is, would these risks be worth it for a space telescope that is mostly functioning normally? Still, it would be an exciting mission, if for no other reason than to be able to assess how Chandra is holding up after more than 2 decades in orbit. On March 24th, 2 more CubeSats were yeeted from the Japanese Small Satellite Orbital Deployer aboard the ISS. The first satellite was Kitsune, the first 6U, or 10 by 20 by 30 centimeter CubeSat deployed using the JWST. It has a camera capable of taking 5-meter resolution images. Kitsune also includes an amateur radio payload that will transmit a Morse code beacon that will describe the status of various systems aboard the satellite. It will also be used to demonstrate high data rate communications in the C-band, something not typically done on an amateur radio satellite. The other satellite yoked into space was called IHI-SAT. It is much smaller than Kitsune, being only 3U, or 30 by 10 by 10 centimeters in size. Its purpose is to track ships at sea using the automatic identification system carried on most commercial ships. Knowing the position and speed of ships helps avoid collisions and can aid rescuers in the event of an emergency. The sensor on IHI-SAT improves on previous ones by being able to identify more ships in crowded areas.
Not everything we report on here at Daily Space has to be about rockets and satellites. Sometimes there are stories about space art to share with you, such as the Moon Gallery that traveled to the ISS aboard Cygnus NG-17 in mid-February of this year. Moon Gallery is a purple rectangle with 64 1-centimeter square cells on one end. Each square has a small artwork, such as a tiny painting or a small statue, made by artists from around the world. Berlin-based Russian artist Christiana Akin said, "Moon Gallery is an incomparable challenge and a chance to rethink the art practice at a drastically new level. It is a chance to ask yourself a truly meaningful question and to test yourself to find a truly meaningful answer. Meaningful for yourself and for the universe, but only within a 1 cubic centimeter. In addition to being a home for art and space, it has practical purposes. The effects of radiation and partial gravity on the various materials used for the works of art and the nanoracks housing itself will be examined for the full duration of this journey." The Moon Gallery has another practical purpose too. It will also serve as a camera calibration target in the NanoRacks Nanolab on the ISS for 10 months before being returned to Earth. The gallery even has its own mission patch, which has a black background and the Moon Gallery word mark in the center against a background of stars. One of the O's in the word moon is a grid of 64 little squares representing the cells containing the pieces of art, while the other is a depiction of the International Space Station. Around the outside of the mission patch are references to the NG-17 mission, the year it went to space, and references to the ISS Payload Gallery and Moon Gallery. The Moon Gallery Foundation plans future space galleries, and the ultimate goal being to place one on the moon. According to the moongallery.eu website, it is becoming the seed of a new interplanetary culture. Next up, we're going to talk about new research from Gaia on white dwarfs. And later, Eric will be reviewing a macro lens. Stay tuned. In the last episode, I wrote what was essentially a love letter to Gaia, and today I bring you yet more amazing science from my favorite telescope. In a new paper published in Monthly Notices of the Royal Astronomical Society, and led by Danielle Mikola, researchers used data from Gaia to discover that white dwarf stars have two different distributions, both in how they move and how bright they shine. White dwarfs are the leftover cores of stars like our Sun and smaller. They are no longer undergoing nuclear reactions, and their outer atmospheres have been exhaled to form planetary nebulae. These stellar remnants start out hot, but over time cool off and fade away. If white dwarfs were simple objects, we could readily calculate how they cool in the same way a physics student might calculate the cooling of a rock heated up in a fire. This would also allow us to figure out things like how long the white dwarf has been there hanging out cooling, and that in turn would give us an estimate of the age of the stars they're hanging out with. But white dwarfs aren't simple, and how they cool changes not just with how big they are, but also according to composition and potentially also according to crystallization. In some models, the highly dense material in these moon-sized objects will change phases, suddenly turning into massive crystals as they cool. This state change causes the star to temporarily reheat before rapidly cooling. The details. They can be modeled, sort of, but are highly dependent on a lot of things we don't always know about the stars we are looking at. Here's what we actually know. 120,675 white dwarf stars in Gaia data sets were analyzed by color, brightness, and motion. One of the populations is brighter and has stars with a wider distribution of velocities, and some of the white dwarfs are truly massive. For still minuscule white dwarfs, they're massive. According to the paper, the bifurcation seen in Gaia clearly has contributions from both atmospheric differences as well as different white dwarf mass cooling tracks. It remains unclear whether the origins of the massive white dwarfs in recent bursts of star formation, or a pileup of white dwarfs with a mixture of ages due to delayed cooling from crystallization, or a mixture of both. And this is what makes science interesting. Sometimes you can get at the same result by following different paths, and we are always trying to understand, is it one or the other, or both? Here, it looks like the universe is playing a game of yes and allowing two different families of stars to emerge. We've said it before, and we'll say it again. Astronomy advances through the back and forth development of both better computers and better telescopes. For the past several decades, we've all held up the same illustration, that on one piece of paper goes from the cosmic microwave background light from the moment the universe became visible, and then in cartoon ways, on an 8.5 by 11-inch piece of paper, evolves from that light to the Swiss cheese structure of the galaxy clusters and voids that we have in our modern universe. With surveys like the Sloan Digital Sky Survey and Dark Energy Survey, astronomers have been able to map out the distribution of galaxies at different periods of time and see how they match this diagram to a point. Well, we can see the cosmic microwave background, and we can see the distribution of galaxies changing over time. There is a period early in the universe that we know almost nothing about. Depicted in old diagrams as a lot of glowy gas and called the Age of Reionization, this is the period when the universe went from a lot of neutral gas to starting to form galaxies and stars. And this is a period of time that we haven't been able to survey yet. With the JWST so far seeming like it just might be going to work, we're starting to feel like maybe we will finally be able to survey the parts of time that allow us to fill in more details. With these observations in, we hope, the nearest future, modelers have been working to define the details of those early days. And they are getting really cool results. The early universe saw more of an evolution of state than of structure. While the gas and dark matter density did change over time, the biggest changes seen in the models were in the amount of gas that was ionized and thus transparent, and the overall temperature of the gas, heating up as the first stars turned on. If JWST lives up to its potential, we will be able to start seeing these pockets of visible and transparent gas around galaxies. Just as star-forming regions here in our galaxy are wild structures of material that are forming stars and reveal pockets of these stars in the gas, young galaxies are pockets, really, really big pockets of stars in the early universe. And we will get to see this, not just in these computer models, but in the universe, if JWST works. There's a lot of hopes in that one spacecraft. A lot of hopes and dreams for science. On a brighter note, next up, Eric brings us a review of a lens that does work and gives wide-angle views on the world and the sky, or really up-close views. Stay tuned.
This lens is a little unusual. It's a third-party lens made by Chinese company Venus Optics, which makes specialty lenses like ultrawide, macro, and even tilt-shift lenses for a variety of camera mounts. It is the Venus Laowa 15mm f4 macro. Now, many manufacturers call lenses with magnification ratios from a quarter to a half or higher macro lenses. This isn't one of them. According to the specs, it focuses all the way up to 1:1 magnification, so an object 36mm long will fill the frame. The ultra-wide angle view combined with the 1:1 magnification allows you to make quite interesting images. One of the example uses for this lens, according to Venus, is for showing small insects in their natural habitat. But there's a catch. The lens to subject distance at 1:1 magnification is just 4.6mm. That's about the size of your pinky's fingernail, which means you'll probably block almost all of your light with the lens in front of your subject at that distance. And you'll probably scare the insects away, too. Another catch is that the lens is fully manual, without any electronics in it. This means you'll need to manually focus, and your camera's auto exposure mode will almost certainly not function. The manual focus and aperture rings, however, are nice and big, and with focus peaking on my Canon RP, I had no problems manually focusing accurately. The lens body and mount are all metal, and the hood is plastic, which isn't uncommon. Overall, the build quality was nice. It's a very solid feeling chunk of glass. In addition to a Canon EF version, Venus Optics makes this lens in Nikon F and Sony A and E mounts, and there's a Leica L mount version too. I used an adapter with the EF mount to use it with my RP. Speaking of the Canon EF version, you need to enable the release shutter without lens option to be able to use this lens, because without any electronics in the lens, the camera has no idea that there's a lens attached. On the RP, it's custom function tab 7. If you use a body with in-body image stabilization like the R3, R5, or R6, you can use that feature with this lens after you manually input the lens's focal length into the menu. The quality of the images was good with no geometric distortion. There are no corrections applied in camera, unlike my other lenses, because of the lack of communication between the lens and camera. But this didn't cause any problems that I could see in the images when I went pixel peeping. The major problem with this lens is the minimum focus distance. In my testing, I couldn't get more than about 0.8 magnification without the front element of the lens hitting the thing I was trying to take a picture of, which is less than was advertised. And when the lens was extended to its highest magnification, I found that the lens hood cast a lot of shadow on the subject. Removing the hood and adding a ring light helped a bit, but not completely. The lens design has a flat front element to allow the use of conventional filters, which helped me avoid damaging the lens when I rented it. This lens also has a shift capability, where the lens body can be moved plus or minus 6 mm in the vertical direction, though I didn't test this out myself. One major caveat is that the tilted image circle only covers APS-C size sensors. This capability is useful for taking pictures of buildings because it will keep the straight lines of the building from appearing to converge. To see this functionality in a $500 lens is unique. Lenses with this capability often run into thousands of dollars. I was excited at the prospects of taking ultra-wide 1:1 macro images, but was disappointed by the actual usability of this lens, and not the build quality or quality of the images. Despite these limitations, I'm going to look at other specialized macro lenses from Venus Optics here on Daily Space in the future, once I share reviews of the other lenses I own and actually use on a regular basis. This has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon and get more content at patreon.com/CosmoQuestX.